So I'm going to give you three different scenarios. One where your lines cross, okay? One where your lines don't cross. Think of these as parallel lines. And one where your lines cross all the time. So you're going to have one line on top of another line, which is actually the same line. To another color. So there's two lines here. Okay. So what you're going to do here is you're going to say, okay, this one is going to be touching one time. So therefore it has one solution. One solution. This one are parallel lines. They never touch. So therefore that one is no solution. And this one is one on top of another line. So they're always touching at every single point. So that one is infinite many solutions. Infinite means they touch all the time. They're touching, 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 touching. So they're infinite means many, right? So one solution, no solution, infinite many solutions. So how do you distinguish from one to another? So if it's y, let's say you have y equals x plus 3, and then you have y is equals to 4x plus 2. Now look at the slopes for these two lines. The m for this one is 1. The m for this one is 4. So the slopes are completely different, right? The b's are completely different. So therefore, they're going to touch one time. That's it. Okay? These, in order for a line to be parallel, they need to have the same slope, but different y-intercept. So therefore, if I do y equals 4x plus 2, and then the other one's going to be y equals 4x plus 3. The main idea here that in order for a line to be parallel, they need to have the same slope. The m for this one is 4. The m for this one is 4. The b, though, is different. They're not the same line. They just have the same slope. Because if this one would have been the same, then it would have been the same line. But they're not the same line. This one has a plus 2. This one has a plus 3. They need to have different b. So I'm just going to write it down. Same m, different b. It says same m, which is your slope, and different b, which is your y-intercept. Okay? For the last one, you need to have y equals, let's say you have 3x plus 2. The other one's going to be exactly the same because it's exactly the same line. Now, sometimes it's not going to seem like it's the same. So you have to put everything in y equals mx plus b. That is the key here. You have to leave it in y equals mx plus b. And you should already know how to do it because we've been doing it for so long. But that is the key. You need to leave it in this format. Once you leave it in this format, you can check if they are the same line, if they are parallel lines, or they are completely different lines. Okay? So that's what we're going to do today. Is everybody good on what I just said?
Yes.
Yeah. All right. So I'm going to go ahead and erase this. I'm going to give you like 5 seconds so you can completely finish writing this down. But I think I gave you plenty of time already. Okay. I'm going to go ahead and erase it. So the main idea right now is you're going to check if they have the same slope, different slopes, or 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 the same line? Okay, so here we go. This is what you have. This one's already in y equals mx plus b. That one's good. But this one is not. So you need to kind of mess with it so that you can put it in y equals mx plus b form. So we already know how to do this. We already know that we have to move the x over. We have to divide by y. How do we know that? Is because y equals mx plus b says that the y has to be by itself. So in order to leave the y by itself, I'm going to move the x, divide by 5. So move the 2x. So now I have 5y. I'm going to put it over here. And then divide by 5, divide by 5, divide by 5. Okay, you're going to cancel those 5s. 20 divided by 5 is 4. I'm going to put plus 4. And this is negative 2 over 5x. This is just y. So what I did is I just put this on top in the front because it's y equals mx plus b. And then 20 divided by 5 is 4. So I put it right here. This is your b, this is your m. So you're going to compare these two lines now. Are they the same line? You have y equals negative 2 over 5x plus 4 and y equals 5x plus 10. Do you have the same line?
No.
And you have parallel lines. Are they the same slope? They're not the same anything, right? They're
No.
completely. So then therefore it has one solution. How are these lines going to look? They're going to have something like this and something like this. And that is going to be one solution because it only touches one time. How can you know? Because they are completely different. They don't have the same slope. They are not the same line. And they have different M and different B. Okay? Are you good so far? I'm going to keep going.
Yes.
All right. I'm going to go ahead and give you another one. So it's going to be y minus x 2y minus 2x equals 20. And then y is equals 2x plus 3. So this one is pretty much set. You don't have to do anything to it. The m here is 1. The b is 3. I'm going to move the x plus 2x. Remember, you always move the x, divide by y. This is in standard form. So move the x, you divide by y. So I'm going to move the x, so plus 2x. You cannot combine these. This one has an x and this one doesn't. So it'll be 2x plus 20 equals 2y. And then you divide by 2 here. Divide by 2, divide by 2. Cancel, cancel. You have y is equals to 2 divided by 2 is 1. So it'll be x plus 10. What do you notice now? They have the same what?
Slope.
Same slope, different b's though. They're not exactly the same line. They're just what? What kind of lines are you going to see here? Parallel lines.
The no solution one, right?
So they never touch, so therefore it's no solution. Very good, Margaret. So this one is no solution. So you need to kind of look at the slope and the b. Now, you cannot do that unless they are in y equals mx plus b form. Okay? I'm going to keep going.
Wait.
Okay. Here we go. So I'm going to give you another one. 5x plus 2y is equals to negative 10. And then I would give you 10x plus 4y is equals to negative 420. Negative 20. Okay. We're going to check if there are one solution, no solution, or infinite many solutions. Many solutions is fine. Just remember that infinite and many go hand in hand. Okay, so 5x plus 2y equals negative 10. I'm going to grab the x. I'm going to move it over. I grab it and I put negative 5x on this side as well. So then I have 2y is equals to negative 5x minus 10. I like to kind of switch them around so that I have mx plus b already. It's just my thing. I think it's a lot easier to read. So divide by 2 here. Divide by 2. Divide by 2. So then I'm just going to rewrite it down here. It's y equals negative 5 over 2 x minus 10 over 2. 10 over 2 is 5. So that's one of my lines. I'll put the other one right here again. So be y equals negative 5 over 2 x minus 5. Okay, and then I'm going to move, for this one, I'm going to move the 10x. How do I move it? You do the opposite of 10x, which is negative 10x. Negative 10x on this side as well. Divide by 4, divide by 4, divide by 4. So now I'm going to rewrite y equals 20 over 4 is 5. 10 divided by 4, you're going to have to simplify by 2 here. So 10 divided by 2 is 5. 4 divided by 2 is 2. And then it has an x, so make sure that you include that x. And it's also a negative, so make sure you include that negative. I'm going to rewrite it on my box so I can actually look at both of them. And now, what do you notice?
They're the same.
They're the same, so therefore, infinite solutions, no solutions, or one solution. I'm going to put right here that they're the same. They're the same line. This one is exactly the same. This one has m. Both the m's are the same and the b's are the same. So therefore, that's infinite many solutions. I'm going to go ahead and stop the recording, but I'm not going to stop the notes, okay?